I was asleep because
For those just tuning in, next Wednesday, homework quiz and master set for 29 or for 28. That's the 20th. The 27th of March, we got the homework quiz and master set for 29, and then on April 3rd, we have the test 1B. It is going to seem strange to be over here, but nice to have a lot of board space. All right, we last left off, we were actually solving a problem. Then I would like to be able to write it down the way what we had. Actually, I'd like to see where we left off.
I forgot my usual note. The last thing I had was this test problem.
All right, and we solved it already using substitution, or do we do Kramer's rule?
I don't think we did that much Kramer's rule because I have written to look it up, so.
Okay, and your notes?
I was not here.
You were not here. All right, so up, down, up, 2, 4, 6. Down, up. This was 2 volts, 4 volts, 6 volts. Start a collection of markers on the floor over here. And was it 1357? What was the? Or 3579?
That one was 5, the one to the right was 3, and the one on the bottom was 7, and the one in the middle was 9.
Okay. And I assume we did not do mesh analysis. Does the term mesh analysis seem familiar? All right. I guess we did this 2 weeks ago, because none of you bothered showing up last Wednesday. Is that a fair assessment? It's spring break, so I didn't show up either. So, all right. Sort of part refresher. In the first technique, you establish, I have 2 junctions here. And I need to get from one junction to the other. I have 3 different paths to take. So I'm going to create a current, 1 current per path. It does not matter whether I go from the bottom to top or top to bottom, and I can mix it up. It really does not matter. I'm just going to, for the sake of this, I'm going to call this B. I'm going to call that one C, and call this one D. I generally start with A, and probably on the videos I do A. However, A is also for amperes, and we're dealing with currents. Any one of them I could have had in a different direction. It just doesn't matter. You assign it and live with it. The next step is to come up with the voltage loop equations and the junction. Well, I have 3 unknowns. How many equations do I need? 3 independent equations. And so one of them will be by using the junction rule. I know current flows in, it must equal the current flowing out of any junction. And so I have B plus C plus D equals 0. Because I have three currents flowing into the junction and nothing flowing out. I believe last time I had at least one of them coming out. I need 2 more equations. My other two equations will be based upon the voltage or loop rule, that I'm gonna gain potential and lose potential as I go around a loop, and I should be back to zero when I get back to where I started. So I gain 2 volts. So I'm gonna start here. I have basically 3 different loops. Well, I have 2 different loops, the third one's dependent on the other 2. I have my right loop, I have a left loop, and I have the entire loop. I need 2 of them, because if I have 2 of them, I can derive the third, so that's why I can't just do all 3 equations. Although I did have a student a number of years ago who did all 3 equations based on the voltage rules, but made a mistake somewhere, so she actually came out with an answer as opposed to getting something clever like 0 = 0. All right, so I'm gonna start here, and this is just my own eccentricity. I like the first number to be positive, but that's a me thing. And I tend to go clockwise, but I don't have to. So I'm gonna start here, I'm gonna work my way around, I'm gonna do my left loop here. So when I go across my battery here, I'm going from negative to positive, I gain potential. I gain 2 volts. I'm now going across my 5 ohm resistor here, I'm going with the current, and current flows downhill. This is a sort of a way of thinking about it. Current flows downhill, so if I'm going with the current, I'm going down, so I'm losing. I'm gonna lose 5 times D. That's just Ohm's law, that the potential drop across the resistor is the current times the resistance. Continuing down, I'm now going against the current, so I must be going uphill. So I'm going to gain 9C. I go across my 4 volt battery from negative to positive, so I gain 4. And then finally, coming across my 7 ohm resistor here with my current D, minus 7B equals 0. So each component contributes a term to my equation. And then we have our last equation. I can do either the right loop or the whole loop. Anyone with an opinion?
Right loop would be faster.
Okay, so I'm going to start here, and I'm going to work my way around counterclockwise. Just again, because I want my first number to be positive, and that's, again, just the childhood scars. So I gain 6. Going across my 3 ohm resistor with the current which I've labeled as D, so minus 3D. I now go down my 9 ohm resistor plus 9C plus 4 equals 0. So dramatic pause for questions about how we came up with these 3 equations. All right, let's set it up so we can actually use Kramer's rule here. What I'm going to do is I'm going to get the equation so that I'm going to do it so that all the B terms are first, C terms are second, D terms are third, equals, and then my constants over on the other side. So my first equation, I'm going to keep as is. So I have B, 1B plus C plus D equals 0. My second equation, I don't have a D term, but I got a minus 7B and a minus 5B and a minus 7B, so I've got negative 12B. I have 1 C term plus 9C equals, I've got 6 on the left-hand side, so I'll have negative 6 on the right-hand side. And then, my third equation, let's see, I don't have a B term, but I have a C term. I have 9C minus 3D equals negative 10. questions to hear?
Refresh my memory, because it has been 2 weeks, the determinants. How many of you have dealt with determinants before? 1, 2, 3, all three of you? Comfortable finding determinants? All right. Sorry, was PJ speaking for everyone?
Yeah.
You're all, okay.
So when doing Kramer's rule, if I'm gonna solve for the first one, because I have them lined up, my denominator is actually gonna be the same for all three of them. So my denominator is just the coefficients. So I have 1, 1, 1, negative 12, 9, 0, 0, 9, negative 3. My numerator, because at this point I haven't brought my constants into it, so I have to do that at some point. So for my numerator, this is where they will differ for each of my fractions. If I'm solving for the first variable, I replace the first column. Solving for the second variable, the second column. Hopefully you see the pattern for the third variable. So my numerator is going to be, I'm going to replace my first column with 0, negative 6, negative 10. And the other two columns are the same. And so, solving determinants at this point, depends on the technique or your comfort level. I'm just going to rewrite the first two columns. So I multiply that diagonal. So that's negative 27. That diagonal plus 0. That diagonal plus negative 108. Minus, now the diagonal's in the other direction, 0. Plus 0, plus 36. And so this becomes negative 135 minus 36, or negative 171. Now, there are loads of places to make a careless error. I'm hoping that somebody will point out any careless errors I make. My numerator, I'm just gonna write the first two columns again. 0, negative 6, negative 10, 1, 9, 9. So I multiply that diagonal, so it's 0. That diagonal, the negative 10 is there, plus 0. And then that diagonal, negative 45. Minus, not going the other direction.
54 or 50?
54, thank you. Not going that way. Negative 90. 0. 18. So I got negative 54 minus negative 72. Which is 18. Amperes. And that, whatever that happens to be, hopefully it's the same thing we got last time.
Yeah, it's the same.
Okay, what is it in decimal?
Negative 0.10526.
102526?
10526.
526, okay. Questions to hear? Now, is there determinants? Are you good with determinants? No? Have you done determinants before?
I don't remember.
You don't remember? Okay. This technique that I did right here only works with 3x3s. A 2x2, though, in general though, a determinant is, we'll just take that bottom one where I got 1, 1, 1, negative 12, 9, 0, 0, 9, negative 3. You can start anywhere. I recommend starting in the upper upper left-hand corner. Just because it doesn't matter how you do it, and so it's just the simplest, but for the purist out there, there's more than one way of doing it. You start with that, and you write that number down. And then you cross out that row and column, and what you're left with is a 9, 0, 9, negative 3. Minus, because as you do terms, you alternate signs. The next number, take that one right there, 1. Cross out that row and column, and I'm left with negative 12, 0, 0, negative 3. Plus, because again, we're alternating. The next one, 1. Cross out that row and column, and I'm left with negative 12, 9, 0, 9. Now I have a 2x2 determinant. I start in the upper left-hand corner, 9. I cross out that row and column, so I have 1 times 9, and what I'm left with is just negative 3. Minus, go to the next one, 0 times 9. Down here, so that's gonna be negative 27. This will end up being negative 1 times, I got negative 12 times negative 3. Minus 0 times, cross out that row and column, 0. Which is negative 36. And the last one, 1 times, I got negative 12. Cross out that row and column, I'm left with 9. Minus 9. Cross out that row and column, I'm left with 0. And so that ends up being negative 108. So my final answer for the determinant is negative 27 plus negative 36 plus negative 108. I do videos where I go through this more slowly, so, and also you don't have to use Kramer's rule. But usually there's somebody who prefers Kramer's rule to the others. So that's 63, 108, you end up with the same thing. It turns out that doing it this way is the same as if I just write down the first 2 columns again and just start doing the when I'm going from upper left to lower right, I multiply those together. I multiply those together, and then add those products. Minus going in the other direction. And so the shortcut for a 3x3 is just to do it this way. A shortcut for a 2x2 is just 8 that diagonal minus that diagonal. So this one right here would be 0 times, I'm left with those 2 when I cross out that row and column, and that would give me negative 27 minus 0. Plus 1. Cross out that row and column. I have negative 6 times negative 3, which is 18. Minus 0. It should be minus 1. plus one. Cross out that row and column, and I've got negative 54 minus negative 90. And so I end up with 0 minus 18 minus 30 plus 36, which is 18, which is what we had before.
Where does the top matrix come from again?
Top matrix, it's similar to the bottom matrix, except we change one column. So since I have B listed first, I'm gonna change the first column when I'm solving for B. And I put that into the first column. Alright, to solve for C, we're gonna do something similar. Using the magic of an eraser. My denominator is gonna be the same as it was before, so I don't have to do any thinking on that one. But I did have a 152 student who recently got 3 different denominators with the same determinant. My numerator is going to be, my first column is 1, negative 12, 0. My second column is going to be 0, negative 6, that's a 0, negative 6, negative 10. My third column will be 1, 0, negative 3. So it should be the same as the denominator, except for the second variable. I changed the second column. And so I end up with 18, 0 times 0 times 0, and then 1 times negative 12 times negative 10. And then going the other direction here, I got 0,